This is video number 4 for the assembly programming and reverse engineering course. And in this video I will talk a little bit about the different CPU register. A CPU register is built of digital logical circuits. The CPU register can be used to store data. It's extremely fast, and reading or writing data to a register is way faster than to a memory address. And if we want to read or write data from RAM, for example, then data needs to go over a bus from the RAM to the CPU, and that costs time. A bus is something like a physical wire that is used to transfer data from A to B or from B to A, but the size of the data that we can save in CPU registers is pretty limited. So that are the general purpose registers. That are the registers that we will use most of the time. Okay, then let's start with a RFLAGS register. That is an accumulator, and it's used for arithmetic results and function return values. So if that is the first time that you hear anything about CPU registers, then it will probably not make so much sense for you. But yeah, in later videos I will explain what we will see what that actually means. So, but for now, I will just go through the registers and I will just explain the purpose of the different registers. So, okay, the next one is RBX, that's a base register, and functions will not change the value of this register. RCX, that's a counter register that's used for counting operations like REP or loop. RDX, the purpose is for data. It's holding the high order bits and multiplications and divisions. It's also used in register pairing, RDX and RIX. RSI, that's the source index, and it's used as a source register for string operations. RDI, that's a destination index, and it's used as the destination register for string operations. RBP, that's base pointer or stack frame, and it's base of the current stack frame that is used to reference logical variables. But yeah, maybe for a very short explanation, if we have something like this and something like this, so that means remove the value 3 into the RCX register, then remove the value 2 into the RAX register, and add RAX RCX. That means basically just this. So it's just calculating 3 plus 2, and the result goes to the RAX register, and then we can see it's used for arithmetic results. And yeah, that is basically what it's doing in this example. Okay, and then we have there is still the stack pointer. So it's the RSP, and this points to the top of the stack. In later videos we will also talk about the stack. And from A8 to R15, these registers, they don't have any specific purpose. But when we talk about API calls, then we will see that RDI, RC, RDX, RCX, A8, and R9, and also the stack, that will also become very important when we talk about API calls. And then we have the next one, that's the EAX, AX, AH, and AL. And all these registers, they are basically included in the ARX register. Okay, so if we take a look, so we can see, so this is 1 byte, this is 1 byte, and this is 1 byte, this is also 1 byte. So 1, 2, 3, 4. Then we have 4 byte and 4 byte that are 32 bits. And this is the low part of the AX register. And this is the high part. Okay, now what we can do is, I don't know if there's a graphic. Okay, I can just use this one. So we can see this RAX, so this one. Then we have 32 bits. This is the high part, this is the low part. And the 16 bits, that's 2 byte. So you can use a different color. So this is 1 byte. And this is also 1 byte. So this is the AX register. It's a 16-bit register, as we can see here. And then we have the high part and the low part. So AH, that's the high part of AX, and AL, that's the low part of AX, basically. So this is AL, and this is AH. Yeah, and that is basically how it works. Okay, so there's a exercise for you. Just try to solve this. It should be pretty simple now. Yeah, if you need a hint, then just go through this. Yeah, then you should be able to solve that. At the end of the video, I will also show the solution. Then we can talk about the RFLAG register. The RFLAG register, that is a 64-bit register that records the outcome of a logical or arithmetic operation. And here we have the most important bit flags for us. The zero flag, overflow flag, carry flag, sign flag, and the direction flag. And later in the course, I will show how we can use these flags. Here's an example for a logical operation. RBX gets the value 1. RCX gets also the value 1. CMP, that means compare. It compares if RBX holds the same value as RCX. And if both register holds the same value, then the zero flag gets the value 1. And otherwise it gets the value 0. Example for arithmetic operation. RBX gets again the value 1. RCX gets the value 6. Sub RBX, RCX. And sub, that means subtract. So we subtract the value in RBX from the value in RCX. In this case, the calculation would be 1 minus 6. The result is minus 5. And if the result of the subtraction is negative, then the sign flag gets value 1. And if the result of the subtraction is positive, then the sign flag gets value 0. And here's an overview from AMD for the other flags. And we can also take a look into the AMD programmer's manual. There's also a manual from Intel. But here on page 70, for example, there we can find more information about the RFLAGS, and also in the second volume on page 114. And there are 3 more volumes. So yeah, there we can find a lot of information. And of course, there are not only the general purpose registers, so there are also way more registers, but yeah, we'll talk about that later. So for now, I think it's better not to focus on too much stuff at once. And here's the solution for the exercise. Okay, so where's AX? That's here. This is 1 byte. This is 1 byte. That is AX. And here we have AL. And here we have AH. And I will also put a link to this document in the video description. And that's it for now.